All right, so we should have already filled in quadrilaterals, quadrilaterals having 4 sides. We should have already filled in parallelograms. We talked about those the other day. You know, what makes it a parallelogram? Opposite sides are parallel. And then the 4 properties that we filled in, which were opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, meaning they add up to 180, and diagonals bisect each other. So that's just a little recap. Now we're going to move on to rectangle, rhombus, and square, which I want you to understand. Rectangle, rhombus, and square are all types of parallelograms and all types of quadrilaterals. So whenever you read this family tree, you always read from the bottom up. If you tell me it's a square is a type of rectangle, a type of rhombus, a type of parallelogram, and a type of quadrilateral. A square is kind of all the above. So it's some of those questions where, you know, you read a rectangle is always a square, and those are going to pop up in your homework tonight. Is a rectangle always a square? Well, a rectangle is not always a square, but sometimes it is. Is a square always a rectangle? Yes, a square is always a type of rectangle. Why? Well, let's start with definition. Definition of rectangle is something that has 4 right angles. Well, does a square have 4 right angles? Yes, then it's a type of rectangle. Are opposite sides parallel? Yes, it's a type of parallelogram. So you always want to read this kind of from the bottom up when you're classifying. So rectangle has 4 right angles. And what's our special property about a rectangle? Our special property is that diagonals are congruent. Diagonals are congruent. Now, since a rectangle is a type of parallelogram, right? A rectangle is a type of parallelogram. You also have everything we learned about parallelograms. So in a rectangle, I'm going to make this a rectangle here. In a rectangle, yes, opposite sides are congruent because it's a parallelogram. Yes, opposite angles are congruent because it's a parallelogram. So a rectangle is a type of parallelogram. So, like I said, when you're always reading this, you're reading it from the bottom up. You're going to tell me, hey, it's a rectangle. And you're going to see if diagonals being congruent helps you. If it doesn't, try parallelogram because it's a type of parallelogram. Moving on to rhombus. What makes something a rhombus? Well, we're going to have 4 congruent. There's your symbol for congruent. 4 congruent sides. So a rhombus has 4 congruent sides. Don't know anything about the angles, just know 4 congruent sides. A lot of people make the mistake of calling this a diamond. I hear that one all the time. So 4 congruent sides. What are my 2 properties? So in addition to everything we know about parallelograms, we're going to add 2 more. If it's a rhombus, diagonals will be perpendicular. That's your symbol for perpendicular, an upside down T. So what does that mean? That means your 2 diagonals are going to cross to form a right angle. And actually technically 4 right angles, but I'm not going to mark them all. So diagonals are perpendicular, and diagonals, this one's a long one, bisect opposite angles. So what does that mean? Let me draw a little rhombus here for you. Oops. We're going to pretend that was good. So let's say this was 20 degrees. You know, if this is a rhombus, let me go ahead and mark that. If this is a rhombus, you know the diagonal bisects. So you know if this one's 20 degrees, this one's 20 degrees. You also know it's a type of parallelogram. So you know opposite angles are equal, which makes these each 20 degrees. So it actually tells you a lot of information just knowing that one thing. And then if it's a rectangle and a rhombus, so if it has 4 right angles and 4 congruent sides, then yes, it's a square. And notice there's nothing special about square because square gets everything. In a square, diagonals are perpendicular. Diagonals bisect opposite angles. Diagonals are congruent. And then everything we learned about parallelograms is also true about a square. So a square actually does have a lot of properties. There's just no special ones that are only for squares. So let's move on to our notes. So that's what the first part of these notes is talking about. They kind of gave you, what a rectangle is. It has 4, right? Oops, let me turn on my marker here. It has 4 right angles. This is everything we just talked about. Yes, a rectangle is a type of parallelogram, and your diagonals are congruent. So we know HK, if HK is 10, GJ is 10. Rhombus has 4 congruent sides. So again, yes, a rhombus is a type of parallelogram. We talked about that. The diagonals are perpendicular, so notice that right angle right there. Technically 4 right angles, but when you draw 4, it kind of complicates the picture sometimes. And the opposite angles are bisected. So notice here, this one, this one, this one, and this one. And that was that example I gave you when they were all 20. So let's do some stuff here. All right, so this first one says BD. They want us to find BD. Well, we're going to have to use some stuff going on in this picture. We know ED is 6.5. Well, a rectangle is a type of parallelogram, and remember, diagonals bisect in a parallelogram, so this should also be 6.5. So when you're finding B to D, you actually have 6.5 plus 6.5, and you got 13. CD, well, if AB is 5, CD is 5 because remember, a rectangle is a parallelogram. So opposite sides are equal. This is inches, by the way, sorry. AC, and this is where we use what we learned about a rectangle. Diagonals are congruent. We knew BD was 13, which means AC should be 13. You don't even have to do any math there. It should be equal to BD. Diagonals are congruent. And then AE is 6.5. So it's kind of nice in a rectangle, they all wind up being the same here. All right, not too bad. Then we're going to move on to rhombus. So again, we're going to use everything we know about rhombus or parallelogram because a rhombus is a type of parallelogram. The first thing they want me to find is KL. And you might say, oh no, there's nothing here, right? There's nothing on KL. But if we remember the definition of rhombus is 4 congruent sides. So you know LM, MN, KN, they're all the same. They're all equal. So even though we don't need these 2 sides, we're going to go ahead and say 3x plus 4 has to equal x plus 20, right? Because it's a rhombus, the sides have to be equal. And then whatever I find for my side, it should be the same as LK. So let's find it. We're going to subtract x from both sides. Oops, not bad. We're going to subtract 4 from both sides. And we're going to divide both sides by 2. So we found x was 8, but be careful, that's not what they asked for. They asked for KL, they asked for a side length. Well, all the sides should be the same, so we can plug it in anywhere. How about here? So we're going to say 8 plus 20 gets me 28. Again, you could have done it here as well. 3 times 8 is 24, plus 4 is 28. Every side is 28 because it's a rhombus. The next one asked you for the measure of angle MNK. MNK. MNK is this whole angle going on here. Well, we first need y, right? You need y. But I don't see anything I can set it equal to here. So we're looking in our picture for another y. Well, here's another y. Okay. Well, we know rhombus diagonals are perpendicular. So we know that 9y has to equal 90, which means y equals 10. Well, it's the same y that's here. So sometimes you don't necessarily use what's sitting right there. You can use other variables hanging out around your picture. So let's plug it in. 2 times 10 is 20, plus 5 is 25. So this angle is 25. And then remember, diagonals bisect in a rhombus, so this one's 25. So they wanted M and K. 25 plus 25 gets me 50. So you kind of had to search for that one a little bit, but it's the same y. And then square. So moving on to a square, like I said, if it's a rectangle and a rhombus, it's a square. So if it's both. So a square kind of falls under all the categories. A square is a type of rectangle, it's a type of rhombus, and it's a type of parallelogram. So like I said, there wasn't anything really special about squares. So what they do is they kind of take you back to the coordinate geometry, where they take you to the coordinate plane. The first one says, prove that the diagonals are congruent. So we've got A, B, C, D. A, B, C, D. I'm not going to graph it, but you can if you want to. So you know your diagonals are A to C and B to D. We want to prove that they're congruent, so let's use a distance formula. So AC, remember our shell for our distance formula, and those are both subtraction. So put your x's in one and your y's in the other. So we're on A and C. So we're going to say 1 minus negative 1, 1 minus negative 1, and then 8 minus 0. So we're going to have 2 squared is 4, and 8 squared is 64. And we're going to be lazy and just stop there. We just want to prove they're congruent. So there's one of them. And then BD is the other one. So let's prove that BD is the same as AC, hopefully. We'll find out. And there's our shell. So BD, where are we? We're here and here. So we've got 4 minus negative 4, and then 3 minus 5. So 4 plus 4 is 8, squared is 64, and then negative 2 squared is 4, and we get the square root of 68 again. So we know the diagonals are congruent. Yes, it's a rectangle. The next one says diagonals are perpendicular bisectors. So perpendicular, you just have to check slope. So slope would be the slope of AC. So slope is subtract your y's. So we'll do 8 minus 0. And then subtract your x's. 1 minus negative 1. So we have 8 over 2, which is 4. And then the slope of BD. Slope of BD, subtract your y's. I'm going to go 5 minus 3. I like to keep them positive if I can. So I did 5 minus 3, which means I'm going to do negative 4 minus 4. So 5 minus 3 is 2. Negative 4 minus 4 more is negative 8. And we get negative 1/4. Right? Those are both divisible by 2. So this right here, 4, positive becomes negative. And 4 over 1 becomes 1 over 4. So yes, that is a perpendicular slope. All right, that's about as far as we're going to go. They do have you do bisect as well, and if you look up here in step 3, they'll show you an example where they find the midpoint of each. I'm just going to run out of time though. All right, bye guys.